Hello, math students. Welcome back to our module called Linear Equations. This is lesson 13, and it is called the graph of a linear equation in two variables. Our goal for today we will learn what a linear equation looks like on a graph and why it looks the way it does. All right, the question that I want you to think about is, why does a linear equation look the way it does? Okay, so first thing I want to do is check this out. It says graph this line, 3x minus y equals 8 on the coordinate plane. Okay, so first thing that we have to do is we have to figure out what our ordered pairs would be, right? And we have to know how to do that by determining the x values. So the first thing that I would like to do is figure out what this is exactly showing us. And so in order to do that, we have to figure out how we would put it on the graph. So for me, if you're remembering from our lesson from yesterday, this right here is written in standard form. So in order to figure out what it looks like or what it equals, I would like to take this standard form right here and I would like to turn it into slope-intercept form so that I can get some points and figure out what we're doing. Okay, so I'm going to take this equation right here, 3x minus y equals 8, and I am going to turn it into slope-intercept form. And if you remember slope-intercept form, it is supposed to be y equals mx plus b. So I'm trying to get it to say y equals mx plus b. Okay, so that means the y has to be by itself. So to get the y to start to be by itself, I have to unhook these two or unlatch them, right? So right now I know this is 3 positive x's, so it's 3 positive x's, so I'm going to subtract 3 x's from it, or take 3 negative x's, which gives me a 0 pair. But what I remember is what I do to one side, I have to do to the other. So now I have to subtract 3 x's from this side. This gives me a 0 pair, so what I have left is negative y equals negative 3x plus 8, because 8 is positive. Now, the problem that I have with this one is that it's saying it's a negative y, and I don't want a negative y. I want positive y equals mx plus b. So now I have to make this a positive y, and we learned this a couple of days ago, that if you take this whole thing and you multiply it by a negative 1, it will give me a positive y, because a negative 1 times a negative y, a negative times a negative is a positive, 1 times y is still y, so that would be y. And then a negative 1 times a negative 3x, a negative times a negative is a positive, 1 times 3x is 3x. And then a negative 1 times a positive 8 is now going to become a negative 8, okay? So hopefully you guys all saw what I did with that. And now the cool thing is I have this written in slope-intercept form, because take a look at it. Okay, the y equals the y, the m equals 3, and the b equals negative 8. So on this one we have m equals 3 and b equals negative 8, because the value of 8 is negative. Okay, so that's what we have. Now, some of you are going, okay, why in the world did she do this? Well, the reason that I did this is because if you remember what I taught you in the last lesson, I told you that the B tells you where it crosses the y-axis. So if we go back to labeling, which we're always supposed to do on our graph, we know that this is the y-axis, and we know that this is the x-axis. Okay, we know that. So what I told you in the lesson before is that the B tells you where the line, the linear equation, crosses the y-axis, slope-intercept form, the y-axis. Okay, so if I say B is negative 8, then actually on this graph, it's not going to sit, because what do we see right here? We actually have a 0, right? So this is the origin on all graphs. So what I actually have to do is I have to extend this graph down here, right? Because the y-axis goes in all directions. The x-axis continues in all directions, that's 0. So then we're going to say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. So actually -8, when you plot it, remember it's -8 and it crosses at the y. So what that means is the x value has to be 0 and the y value has to be -8. So what I have to do is I have to go over, right, or left, nothing, so at 0, but then I go down to -8 and I put a point, okay? Because this is the y-axis, kiddos, and the B tells me where the line will cross the y-axis, okay? So now the next thing that I have to figure out is I go, okay, so now I have to know what my rate of change is. Well, according to this, the m is what happens right here. So if I say that x is 1, then what I'm doing is I'm taking 1 times my rate of change, right? And that means that I have to go up 3 over 1. And so what I have to do is when x is 1, then I have to multiply that by 3, and that will tell you what my next point would be. So if I go up from here, 3, 1, 2, 3, and over 1, this is where my point should be, okay? So my point on this one now, when x is 1, the y is going to be -1, -2, -3, -4, -5. So this would be -5. Okay, does everybody see that? Okay, so now let's prove it. So if we have y equals 3 times x, which we said was 1, and it started out crossing at the -8, now we have to solve it. Are you ready? So this would be y equals 3 times 1 is 3, minus 8. So y equals, what is 3 minus 8? -5. So we got a -5 right there. So that's how you find that value. Okay, so now let's try another one. Ready? The next one we're going to look for is, well, what if it's 2? Okay, so now we can do the same thing. If we plug in y equals 3 times 2 minus 8, I know that 3 times 2 is 6 minus 8. So y equals 6 minus 8, we get -2. So this one would be -2. Okay, so let's check it and see. So we go to the right 2, 1, 2, and we go down 2, 1, 2. So our next point on our graph would be right there. Okay, so that's not so bad. All right, now let's try, what if x was 3? Okay, so let's try it. Y equals 3 times 3 minus 8, right? So I would go 3 times 3 is 9 minus 8. So now I have y equals 9 minus 8 is 1. So the y is going to be 1 now. So it says go to the right 3, 1, 2, 3, and up 1. And there's our next point. So if you look at it, it's going up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Who can guess what the next one would be? Up 1, 2, 3 over 1. So I'm thinking that might be right. So let's go ahead and try it. So up 3, 1, 2, 3 over 1. We're going to put our dot there and hope we were right. So now let's try 4. So y equals 3 times 4 minus 8. Well, 3 times 4 is 12 minus 8, so y equals 4. So this has to be a 4, so now let's try it. To the right 4, 1, 2, 3, 4, up 4, 1, 2, 3, 4. Ta-da! It worked! It absolutely worked! How cool is that? So kiddos, you have now just discovered how to take an equation in standard form, turn it into slope-intercept form, and then plug in the coordinate values of 0, 1, 2, 3, and 4, and come up with the straight line that is created when you plot those values. And let's prove that it's a straight line by taking, let's do this one. And again, it may not look perfect right here because, kiddos, I had to draw the graph. Remember, if I had a real graph, then it definitely would show a straight line. But that's the trend right there, okay? And so what you can see is we started on where it crossed the y is right here at 0 and -8. Then we are sitting at 1 and -5. And then we're sitting at 2 and -2, right? And then we're sitting at 3 and 1, right? And then we're sitting at 4 and 4. So if you follow the pattern, what would the next one be? Up 3, 1, 2, 3, over 1, and it would be right there. So it would be 5, 5, is it? Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So it would actually be at 7, right? Or 8, excuse me, at 8. So up 3. 1, 2, 3, over 1, so at 7. So anyway, here's our incredible graph, and it followed the pattern of what we were doing, and we were able to see how to graph that linear equation. So again, one more time, change from standard form. So remember that that right there is standard form, okay, whereas this over here is, let me underline both of them so you can see them, this is slope intercept form, right? So we went from standard form to slope intercept form, and then we plugged in the different values of x. And when we plugged in the different values of x, we were able to find the values of y, and they followed our rule or our pattern, and we were able to fill in our table with the values that we needed. Okay, so going back to our goal, today we will learn what a linear equation looks like on a graph and why it looks the way that it does. Okay, so let's go back to this. I forgot this question right here. It says, what is the shape of the graph? Well, the shape of this graph is everybody, what is it? The answer to that question is that it is a straight line. Absolutely. Linear means straight line. Okay. So why does the equation look the way that it does? Well, the equation looks the way that it does. In standard form, it looks like this. And in slope-intercept form, it looks like this, because this right here, this piece, which we talked about, tells you where it crosses the y-axis. And your slope right here tells you how much it moves at the same time. So up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. So this graph right here is what we call a positive slope graph, because the number that was right here that gave us our unit rate, or our constant, or now you know it's called your slope, is a positive 3. So your graph is going up in a positive direction. Okay? So pretty cool. We're learning a lot of cool new stuff, and I can't wait for you to practice it in class. Okay, kiddos, that's all I have for you today. Talk to you soon. Bye.